Today, I want to go more into in-depth about how we would find z-scores. Okay, so let's go more into in-depth about z-scores and the nitty-gritty of z-scores. So first things first, our z-score is basically the distance from the mean in terms of standard deviation. But what does this mean, and how do we compute this, right? How do we use this information to actually find our answers? Well, there are three rules to solving any z-score problem. First, draw a picture. That's rule number 1. 2, draw a picture. And 3, draw a picture. So what our emphasis is, draw a picture. Always draw a picture to know what is it that we are working with and what it is, how do we solve it. So let's say we have n, right, normal distribution, and it is let's say it is the mean of 50 with a standard deviation of 10. Okay, mean of 50, standard deviation of 10. Well, then what does that actually mean? So if I drew a quick graph, right? If I drew a quick graph, the middle is going to be 50, and then we go out 10 each time. So this is 10, oh, not 10 though, this is 40, this is 60, this would be 30, this would be 70, and if I draw a line of our bell curve, that would be the highest, and it kind of goes down a little, kind of goes down a little, don't have to be like artists here, but then this goes down a little bit more, so we have 1, 2, 3, and then at the next part it gets really close to the end here, right? And this is 20, and then this is 80 here. Well, what does this actually mean? Well, this means between 40 and 60, we already said there is 68%, right? So if there is 68%, then these have 34% in them. There must be a 34% or a 0.34 when you're talking about numerics, right? A 0.34, 0.34. These small ones have a 13.5% or a 0.135 when we're talking about numerics. So 0.135, 0.13, 13.5, because, right, we do, the rest should add up to 95%, and then the outer parts, right, the remainder should then add all this, most of this bell curve should be 99.7, so you add this, these two small ones should be 2.35%, 2.35%, or 0.0235 numerically, 0.0235 numerically, and the rest, right, the little last part, the very tiny minute part that goes down to 10, goes up to 90, well, these are the tiny 0.15% or 0.0015. So the same goes with the other side that way. Here, this is 0.15% or 0.0015. So that is how to talk about it. So if a question asks you, right, what percent falls between certain scores? Let's say the question asks what is what amount of people, right, fell between 70 and 40? Well, then let's just look at what is the area that we need to cover, right, between 70 and 40 here. Since we already drew our picture, don't we need to cover these three standard deviations amount? Well, we just gotta, if they want it in a percentage, right, we'll just write add the percentage. So then that's 34 plus 34 plus 13.5. Add that up together. So let's see here. It's 13.5 plus 34 plus 34, and I got 81.5. So that is the percentage of people falling in between that. So now let's analyze this same formula. Now let's once again go over our formula. Our formula for a z-score is our z-score equals our value, our x value, minus our mean, all right? Mean divided by our standard deviation, or we could write it differently, x minus our mean divided by the standard deviation. This one being the entire population. This one stands for our sample size, but either way, it's calculated the same way. Let's say we know that we want to say, let's say the number 43. Let's say the number 43, remember once again, our n is 50, right? Our standard deviation is 10. So if let's say this is, these are test scores, and the average was 50, and the standard deviation between the test score was is 10, the average standard deviation. So then let's say someone scored a 43, right? 43, and up here, if we had a 43, it'd be up here, right? That'd be right there in our 43. And we want to find our z-score. So then we would just put it into our formula. Z equals 43 minus 50, divide that by 10. That should give us our z-score now. Just 43 minus 50 divided by 10. So our z-score should be negative 0.7. So that would be our answer there. It's negative 0.7. So that means it's negative 0.7. So negative 0.7 from the median. So it's below the middle, the average. But let's work it another way. So let's say we know the z-score, but we want to find what that score is, right? Let's say our z-score is, say, 0.6. We want to know what score that a person has to take to be 0.6 or 60 percentile of everyone who took the test. So we'll just plug it into our formula, right? 0.6 equals, we don't know what the number is, so that'd be our x minus 50, divide that by 10. So we're going to just multiply both sides by 10. So that's what, 60 equals x minus 50 plus 50 plus 50. So that one is to get a, wait. That's actually a 6. 10 times 0.6 is 6. That's a 56. And there we go. So if you scored a 56 out of in the test, you were actually at the 60 percentile. And if your z-score then is at negative 0.7, that means you scored 43.